So good morning, everybody. I want to talk a bit about yesterday's lab. There were a lot of big ideas there, actually, and so we're going to spend some time thinking about them and going over them. So looking back at the lab thus far, what things did we do in there that were kind of newest or most challenging to you so far? Anybody?
With cells,
How so?
just kind of figuring out how to manipulate them at all.
Cells manipulation. All right, we're going to go over that in some detail today. Anything else kind of jump out at anybody as like, wow, this was challenging or different or something I had to get used to? I'm going to share some of my own observations as well. One of the concepts of this particular lab is the idea of abstraction. That is hiding details. Whoops, didn't mean for it to fly away. Okay. For example, here is one way in which I saw this pop up. So in the puzzle class, the concept was you have a maze and it gets coupled with an explorer in a position to create a puzzle. And something I observed was when people were setting up their maze, they then tried to treat it as if it were an array, right? The maze itself hides the array, and all you really want to do is interact with it using the methods that it provides. So that's an example of an abstraction. That is, regardless of what the implementation looks like, if you want to find where something is in the maze, you just call getState4. So I saw some of you trying to directly index it as if it were an array, for example. Similarly, with altering it, you use setState4. And I even saw some kind of intriguing and creative ideas that nevertheless weren't really going to work, of like calling getState4 and then trying to make it equal to something. And I'm pointing out these things, certainly not to make you feel stupid or anything, but to point out that a key thing that I want you to learn as you work on this lab is how abstractions hide details. That we use abstractions so that we can think about something without having to think about every last little picky detail about it. So you can interact with a maze in terms of positions without having to think about an array because we've hidden that detail from you. In practice, this turns out to be essential for building software systems that work. That is, keeping track of all the details of absolutely everything is just too hard. And so much of the art of writing good software comes down to setting up abstractions so that you don't have to worry about some of the picky little details. This isn't the easiest idea to completely assimilate. Ultimately, no amount of explaining will do it. It requires extensive practice, which, of course, I'm going to provide throughout this semester. So in many ways, this lab is going to be one of the most important ones you work on, one of the most important ones to get right, because it's about training your mind to think about solving a problem in terms of building different levels of abstraction to help tackle it. Any questions about that so far? Let's talk about cells. Come here. There we go. So, as Caleb pointed out, these have the potential to be a little confusing, especially because I had not talked about the idea of an enum type yet in class. And so we're going to spend some time thinking about the idea of an enum today. So coming back to the sketch pad, one thing we've already talked about is the idea of subtypes, right? So the idea of subtypes we explored in the context of using an interface. And the first interface that we messed with was the idea of the strategy in the iterated prisoner's dilemma. So strategy is an example of a supertype. And any type that supplies certain methods like opponent, move, and is defecting. So regardless of how it implements these methods, any type that implements these, subtype, qualifies as a subtype. It qualifies as a subtype. And we saw that this was a pretty powerful idea because it let us set up a simulation engine that had a big giant array of these things, and it could then just ask each one in turn, here's what are you doing, and here's what your opponent did, without paying any attention in terms of how it was implemented. So a different form of subtyping is something we see with the idea of an enum type. And so cell is an example of an enum type. With an enum type, we have some abstract methods, in other words, methods that can have different implementations. And then we've got a small finite distinct number of values. So let's put these ideas together. So we have finite distinct values. Now, if you're being really picky, which as computer scientists we all should be, any data type has a finite number of distinct values. So in that sense, well, what's the difference with an enum? Well, part of the difference is if I talk about an int and I say there's a finite number of possible values, well, yeah, that's true, but it doesn't deeply affect how I reason about it, right? In particular, I wouldn't think in terms of 2 does different things than 3. You know, 2 and 3 are just different integers and they have the same operations that work the same way. You know, if I add 1, I go to the next integer down the line, for example. With enums, these finite distinct values are, as the name implies, enumerated. That is, I have to explicitly state when I define the data type every possible value that it can take. Again, ints are finite, but I don't really need to declare all 4 billion possible values. And if I did, my program would maybe get a little cumbersomely long. You know, that is not helpful. So if we have these enumerated values, part of the question also arises, where did this come from? You know, what motivated the creation of these things? And part of the answer is that there was a programming pattern that had been common for a very long time, which involved imitating the idea of an enum by using constants. So let's look again at the idea of a cell. A cell can be open, closed, or visited. Now, One way that we could imagine implementing this would be to use some constants. So in other words, I could represent the idea of a cell with an int. And I could say something like open is 0, closed is 1, and visited is 2. Yeah? And just by using those highly specific constant values, I could indicate these distinct possibilities. Now, this scheme has a couple of disadvantages. The biggest and most massive disadvantage is that the range of legal values for a variable of this type includes a lot of values that make no sense. So if I say something like, int cell equals visited, it is legal Java for me to then say something like cell plus plus, right? And at that point, the value of cell has no meaning. It's unintelligible because it's not one of those specific values. So where enums are handy is that they only permit the variable to take on one of these enumerated finite distinct values. And if you try to make it take on any other value, your program won't compile. In other words, it won't even let the program run because you messed up, as opposed to this scenario where the program is allowed to run and you're going to have some kind of subtle and annoying bug down the line as a consequence. So enums are an example of using the type system to catch errors before the program runs, which is pretty handy. Now, what about the other disadvantage? Let's say I want to do different things depending on whether it's open, closed, or visited. If I'm using this integer approach, there is precisely one way I can do this, which is to use some if statements. So I could say something like, if my cell is open, I do one thing, else if cell equals closed, do another thing, else if cell is visited, do a third thing, else things have gotten bad because that value shouldn't happen. Right. With an enum, we can use a variation of this idea of subtyping. That is, instead of using if statements, we can have distinct method definitions for each value, so that each value causes the code to do something different when that method is called. And so the cell is an example of this sort of thing. In the cell, there are, let me go this way. If we go to the bottom, I've declared 3 methods that every value is required to implement. Get color, flipped, and can enter. So get color is supposed to return a color that can be used for displaying that cell. So ultimately, when we've got a grid of these things, a maze, when it comes time for it to be drawn on the screen, each cell is just asked, what is your color? And then the color is just supplied right there. So it makes the code for drawing it on the screen a lot simpler as a consequence. Flipped talks about if I click on this cell because I want to change what it is as I'm editing my map, flipped says this is what it becomes. And can enter says, can an explorer enter this cell or not? Now, if I only had 2 distinct values, some of these would seem kind of trivial. But I have 3 because I've got a distinction between the notion of open and the notion of visited. The reason that I have this particular distinction between open and visited is that when I'm trying to solve the maze, one way that I can keep the searcher from spiraling totally out of control is by marking cells as places I've already gone, using this visited idea. I can still enter them, but when I see that it's visited, I'm not going to search it again. You know, I know I've already checked it. So, nevertheless, I can enter either of them. Similarly with flipped, if I flip either an open or a visited, then it's going to be closed when I flip it because I'm just filling it in. So for each of these distinct values then, we have distinct implementations of these methods. So open cells are yellow. When you flip them, they're closed and you can enter them. Closed cells are brown. If you flip them, they're open and you can't enter them. And then visited cells are aqua. When you flip them, they're closed and you can enter them. And one way this is going to be handy is you can see on the maze, when you try to solve it, what paths the searcher tried before it found the solution. And so it lets you see interesting stuff like, did it have to search every single square in order to find the answer, or was it able to skip some of them? And this will provide a really nice way to visualize that once you get to that point. So that's the cell enum. And that was one piece of this that was challenging, as Caleb referred to. The other piece that was challenging, I'm not going to code this live for you all because it's part of the lab really, was thinking through how do you deal with an array of these things, right? So something that I think each of you discovered eventually was that if you didn't initialize the array with a whole bunch of specific values for your cell, they were all nulls and you got some obnoxious error message in the unit test, a null pointer exception. I'm not going to single anybody out. Let's just phrase it more generally. Has anyone not seen null pointer exception at this point? Good, everyone's seen it. Yeah. Of course, one of my goals, right, is for you all to see null pointer exception perfectly often here, so that later on in your coding career, you know how to avoid it, or importantly, when you do see it, you know what to do about it. So an array of anything other than primitive types, ints, booleans, or whatever, when you create it, is just a bunch of memory addresses that are pointing nowhere. And that's what the nulls were that you got. And so when you set up an array, you actually have to explicitly put data in it. And that was part of what we wound up having to work on yesterday. Last issue that could cause some confusion is just, what do you do with enum values? How do you talk about them? How do you talk to them? So let me pull up cell test for a moment. Actually, cell test is really kind of lame, but it's got a couple of important ideas, and I think I'm going to add a test or two as well so that you can see a little bit more about how to employ them. So what I have here is a special form of the for loop, which is used more commonly in practice than the whole high bureaucracy business with the int I and so on. That is, we can ask an enum type for a list of all of its values. And then we can say, basically, for each of those values, do something. And in this case, we say if the cell can be entered, if you flip it, it can't be entered. And then if the cell can be entered, if you flip it twice, it can still be entered. And so this tests a general property of the ideas of flipping and entering. It kind of talks about a relationship between them that should always hold. But we can write tests that are a lot more concrete than that very abstract test that I created. So I'm going to call this value test. And so let's say I create a cell C and I make it open. In that case, I could also assert true or assert equals cell dot closed cell dot open dot flipped. So when I flip it and it's open, it really needs to be closed. So a couple of key ideas here. Literal values of my enum are prefaced with the name of the type, a dot, and then the name of the value. And I can use them both as in variable declarations and as literal values being passed as parameters or whatever. Oh, actually, I kind of overdid it here. Let's do that. So let close, c dot flipped. Then I could say something like cell C2 equals cell dot visited. And then I might say assert not equals C and C2, right? Those are distinct values, so they're not going to be the same thing. And then I could even say assert equals cell dot closed C2 dot flipped. Because flipping either an open or a visited should result in it being closed. And so if I run this, they both pass. They both pass just fine. You can't really do anything to enum values, like you can't add them, you can't multiply them, that sort of thing. You can certainly replace them, right, though. So for instance, I could say something like this. I could say C2 equals C2 dot flipped. And then I might say assert equals cell dot closed comma C2. So once I've flipped it, it should be closed. And that works fine as well. Of course, if I change this to open, it should fail on me. And sure enough, it fails. I get an assertion error. It expected open, but it was actually closed. But I'm going to do it back because I just hate failure. Certain hardcore aficionados of unit testing go so far as to say, before you even write your code, you should write your test and you should watch it fail before you even code. I'm not going to ask that of any of you because I can't personally bring myself to do that. And part of the reason I can't is often I've got an idea for how to make something work, and it would require kind of shutting down the part of my brain that's making it work in favor of writing the test. So I've personally been unable to do that, but those who work that way tend to swear by it. So I just want you all to know that that possibility is out there. You start by writing a test that fails and then create code that'll pass it. That sort of thing. Like I said, I've never been able to bring myself to do that, but some say it's a wonderful thing. So in any event, that should give you all a feel for what's involved with an enum. Now, as we know, in this particular lab, cell is not the only enum, right? So we're going to talk a little bit about the others and what I'm expecting you to do relative to those. So we have this enum named direction. And so directions take on 4 popular values: north, south, east, and west. North, south, east, and west. And for each of these, I'm asking you to define what it means to go clockwise, counterclockwise, or to get their rotation. So why the rotation? Well, I've provided for you this fun little method that works on any direction called getNeighbor. So if you give it a position, basically it does some trigonometry and figures out, given the rotation, where the next neighbor is going to be, and so forth. I mean, trigonometry arguably being my favorite topic in mathematics, I guess I can't help but talk a little bit about how this works. Basically what it does is it gets the x coordinate from the source and then subtracts the sine of its rotation. Then it gets the y coordinate and adds the cosine of its rotation. The rotation itself, I'm asking you to provide in degrees, and then I'm explicitly converting it to radians here for the use of the trig operators, which are unforgiving towards degrees. But writing out stuff like pi over 2 and the like is just exceedingly cumbersome, I would say. So that's how that particular operation works. So for each of these directions, then, you're going to fill in, you're going to replace, return null with the appropriate direction. So if I'm thinking about west and I'm going clockwise, what direction would be clockwise from west? What's that? North, yeah. I'm facing west, I go clockwise, well, at least it was clockwise to me, and now I'm facing north. So if I'm facing west and I go counterclockwise, what direction am I going to face? South. And so instead of return null for get clockwise, you'll have return north. Instead of return null for get counterclockwise, you'll have return south. And that's essentially what you're going to do for all of these, right? So this one is partly implemented for you, and then you just have to fill in the right values in the right places. That's what's involved there. And then for the heading, I think south was 0, north was 180, and west was 90, and east was negative 90. It's all stated in the lab description. So that's what you're going to do with directions. And turns out not to be super hard, but it gets you a little more practice with this idea of an enum. Now, moving on from there, we have the enum move. And unlike cell, where the implementation was provided for you completely, and unlike direction, where the implementation was provided partially, with move, there's nothing there. So what I'm going to want you to do with move is create an implementation that does everything move test wants. So when you get to that step, you'll comment out all these unit tests, and that'll give you an idea of what I'm looking for. So the instructions, of course, talk it through, but we can see we're going to need a forward value from test forward. We're going to need a left value, and we're going to need a right value. And there's going to have to be a method called new direction that tells you what direction you're going, and new position that tells you where you've gone in the event of a given move. And I'm going to leave all of that directly up to you all to code using the ideas that you will have seen in cell and direction. And that'll give you a lot of practice with this idea of an enum. One of the really fascinating things about enums is that the more you get used to employing them, the more opportunities you're going to find to use them. So in practice, it turns out there are just a lot of situations where you know ahead of time every possible value of your data type. And for each of those values, it does different things. To some degree, I'm saying, trust me, this happens a lot. But I'm also suggesting that the way that this maze solver is set up gives some ideas as to how it crops up a lot. Really, when you're thinking about simulating lots of different systems, it pops up all the time. One of my favorite programs that I've written is a chess program. I'm kind of fond of chess, maybe disproportionately so, in fact. And it turns out this idea is really useful there. Thinking about a game like chess, off the tops of your heads, what kinds of enumerated types might make sense? Yeah, so let's actually sketch out a list. So let's imagine, chess, enums. And so what did you say, Elijah? The piece moves. Okay, what are some other ideas? Good. What are some other ways we might use enums to set up a game of chess?
Each, I guess it's not piece moves, but like for the rook, you have all the methods would be up where you can move. So you can only move X to the left.
Right. So the pieces themselves actually could make a good enum. Good. What are some other things that could maybe come up in chess as enums? So, yeah.
Maybe the edge of the board.
So when we think about the edge of the board, what's the general type of which the edge is a value? Yeah, we could have a notion of a square on the board. What are some other ideas? I think there's some really simple ones we've missed. What are aspects of a chess game where there are distinct but a small number of values? Where small could be as low as 2. The players, yeah. Yeah, the players. What are some other aspects, How many ways can a chess game end?
Three.
3 ways? What are the 3?
Checkmate, white, black, or
That's right. So you could have ending conditions, right? Because black can win, white can win, or you can have a draw. Chess games can tie, after all.
Yeah, it's not physically possible. There's 3 guns.
So about 2 minutes of thinking, and we came up with a fairly massive list of enums. So in practice, I definitely used players, end conditions, and pieces. Piece moves, it winds up being easily expressible with the idea of a piece. So piece moves was a great suggestion because there really is a finite limited number of them. But incorporating them into pieces turned out to be pretty straightforward. And so then what happened was for things like a queen, I set it up so that there was an algorithm that calculated rook moves and an algorithm, the horizontal vertical, a different algorithm that calculated diagonal moves, and then for a queen, it was just their union. And so in that sense, it was easy to reuse the underlying idea. And then actually, I think I did use square as well because it wound up being useful to think about different ways it could be occupied. Is it an empty square, non-empty, that sort of thing. And then that fed into the whole move calculation. So yeah, it turns out this idea was pretty useful. Let's think about another problem domain. So for this next problem domain, let's imagine something more practical, more business-like, less recreational, but yet of immediate importance. Student records. Where might one use some enums if you're representing student records? Where are there some small numbers of distinct values? Yeah.
The grades.
Grades. Whoops. Good. What are some other possibilities? Grades is excellent. Is this the only enum that pops up with students? Yeah. So how so? Why don't you elaborate on that?
They were there, not, or they showed up late.
Interesting, right? So you could have attendance. It's not the type of record that would be stored at a place like Hendrix typically, but it is absolutely stored at a place like a high school, right? So when I get my kids' grade reports every 9 weeks, it lists on there how many absences and how many tardies. Enum.
I would say maybe excused in non-concepts.
Absolutely right. And so that's an additional distinction you could make. You could have an enum for in class, unexcused absence, unexcused tardy, excused tardy. Again, we've got a small number. Yeah, Elijah.
I guess if you drop them.
Yeah. Dropped course. Is the students, still enrolled in a class they signed up for at the start of the term?
The course names.
Okay, so how would course names be an enum?
I'm sorry.
No worries. It was a good guess. For course names to be an enum, at the time I'm writing the program, I would have to enter in all of the course names. In practice, we're probably not going to do that because we want to be able to change names of courses without rewriting a program. So course names are likely to be stored externally, but like what the grades are, that's likely to be programmed in. That's not likely to change. It's not deeply likely that Hendrix is going to go away from A, B, C, D, F. Although at one point, there was an attempt to go to having pluses and minuses, so that you could earn like a B plus and it'd be worth 3.3, or a B minus and it'd be 2.7 on your GPA. What would you all think of that?
No.
No?
Probably no.
Helpful to some people. I see a lot of head shaking. So in general, a bunch of faculty loved this idea and students uniformly detested it. And loud student complaining about the proposal actually led to its death. Yeah, it was interesting how it turned out. Yeah, faculty kind of like it because, we're used to seeing, okay, such and such got an 89.9. Is that really an A? If I can make it an A minus, I somehow feel better deep down in my heart. Or this student pulled an 88, so close to an A, yet so far I would feel so much better if I could just stick a plus. But no. No. I think especially once you get into, I think if you only had pluses and not minuses, students might like it more, but it really was. Just have pluses. Oh gosh, okay. Actually, the school where my brother went to college, Michigan State, basically had that system. So they didn't even refer to them as pluses. They just said, well, you can get a 4, a 3.5, a 3, a 2.5, or whatever. The point is, once you change something that deep, it's pretty easy to imagine that you might have to reprogram something, right?
Yeah, it'd be smart. It'd be smart.
Yeah. So good. So what are some other things we could include in student records that are enums? Yeah, Tate. Yeah. So
I know
something like that. Yeah.
I know this is probably gonna be a subsection in grades, but like 9 weeks grades and semester grades.
So like what the grade is being used for would be a possibility. So that wouldn't necessarily be. It could be an enum. Actually, yeah, that's imaginable. First quarter, second quarter, or whatever.
And then semester, third quarter, fourth quarter.
Yeah.
That's how we do it here.
So we could imagine something like here's how we might express it: a grading period. That could be an enum. Once upon a time, Hendrix had a different system of grading periods. We had trimesters instead of semesters. So there would be a fall trimester, a winter trimester, and a spring trimester. And so students would enroll for 3 classes per trimester, and it would last like 10 weeks. And you'd go to class basically every day, all 3 of your classes. A big disadvantage of the scheme was it kept you in school far too long into the summer, which is bad both on a climate level and on getting internships and so forth, and facing reality in terms of other places being on semesters. We eventually caved and went with semesters. My first semester at Hendrix was everyone's first semester at Hendrix. The trimester system ended the year before I arrived. Yeah, and it was considered a big deal, you know. I was like, oh, there's semesters, what I've always done. But yeah. So the grading period has changed, and that, again, now we're talking actually reprogramming a bit. That starts to make sense, right? What are some other things, other student record issues that could be enums?
Special cases, maybe.
Like what?
Maybe you were kicked from the class, suspended. There was suspension.
We could say student status could be an enum, right? So you've got, like, you know, enrolled, graduated, academic suspension, medical leave, studying abroad.
Yeah.
You know, there are lots of status situations.
I don't see the studying abroad in high school, maybe, but maybe in college.
Oh, it happens in some high schools too. Yeah. Yeah. So this winds up being a pretty natural idea in that context. Let's think of one more. Let's imagine, and really, this is just a slightly different form of what we were just doing, the context of accounting. So where you're tracking things that are paid, things that are payable. Let's just say computers tend to be involved a lot in this kind of thing, right? So what are some enums that might be applicable when you're thinking about accounting? Yes?
Status, paid, overdue, late.
Paid, overdue, oops. Yeah, so kind of the status of the bill. Yeah. There's some other enums that might be applicable here.
If it's taxable or not. It has tax exemptions.
Taxable versus exempt. Good. What are some other ideas? These are great. So we're imagining any entity, right? It could be something that's billed. It could be something about a person on the payroll. Any number of things.
If they're an employee, they get discounts, or if they have a special case.
The discount levels, you know, you could imagine something like that. Yeah. My first job, and I'll talk about this from time to time, was at Little Caesars Pizza. I worked there for nearly 2 years in high school. I learned a lot of important life lessons, but definitely one of my favorite parts was getting a free pizza at the end of my shift. But only some shifts were eligible. See, I had to work a 4-hour shift to earn the free pizza. If I worked less than 4 hours, it was not a free pizza eligible shift. So you can actually imagine that kind of a classification, you know, like the type of shift might play into something like a discount or whatever. The rules were strict. I was allowed up to 2 toppings on the pizza. Just 2.
What you choose? Usually.
Somehow more than 2 occasionally wound up on there. Partly because when I first started there, they just said a free pizza, and they didn't mention that rule. And only later on did I happen to notice it when I was looking over some kind of a book. So early in my career at Little Caesars, I would put basically everything except the anchovies and olives. Curiously, I actually really like anchovy pizza now, but tastes change over time.
Pineapple.
Pineapple was not available as a topping at that time and place. Yeah. But later on, I did stick with 2 toppings, and I think at that time in my life, I think they were usually pepperoni and sausage. At that time. But yeah, that was fun to do. Cool. Any last ideas on accounting? These are some good ideas.
You could do like how many vacation days have been accumulated or medical absences.
Oh yeah, different kinds of absences. Right. And so you could certainly imagine having database fields telling you how many of these are left, but then you would want to record for a given day, was he there or not? And then what was the reason, right? Was it vacation? Was it a sick day? And then you can imagine some code that goes through that record and then populates the database based on those enum values, for example. So wrapping things up then, the theme of today is this idea of an enum. Finite, distinct number of small values, often with different behaviors associated with those different values. And really, in almost any situation you're in, I want you, every time you're thinking about defining a new data type, to think about, does it make sense as an enum? Do I have the small possible number of distinct values? If the answer is yes, you should use an enum, because it helps the compiler give you feedback about whether you've got errors in your code. And it also makes the code easier to understand and to navigate. So think really hard about this stuff between now and Friday. On Friday, I'll talk through a bit more the idea of a linked list to keep track of where you've been in the maze. You should absolutely work on that part of the lab before then, but I'll talk about it maybe in a little more detail than I did yesterday. And then looking ahead to Monday, we're going to start looking at alternative arrangements than stacks for lots of things coming in and coming out of some kind of an arrangement. So, cool. See you then.